with the session. If my voice is clear and if you're able to see the screen properly, please type 1. Again, if my voice is clear, able to see the screen properly, please type 1. Okay, then, thank you very much. If you're able to recollect what we discussed in the last lecture, in the last lecture, we are trying to understand the booting process, booting steps of a Linux operating system. When you switch on the system to when you switch on the system to login screen comes, what is the process background is going on in a simple way we are trying to, not in detail way. And the first process is BIOS, and second is MBR, third is a grub, fourth is a kernel, fifth is a init, sixth is the run level. Yes, S8 is correct. BE9 S8 correct. Every step has its own responsibility. Will you accept this statement? Every step has its own responsibility. Now, can anybody tell me what is the job of this step number 1, 2, 3, 4? What is the step number 4? What is the step number 4? Step number 4 is a kernel. Now, who will load this kernel? Who will load this kernel? Grub will load. What is the meaning of loading the kernel? What is the meaning of loading the kernel? Can I say loading an operating system? What is the meaning of loading the kernel? Can I say loading an operating system? How many components are there in an operating system? 2 components. So the loader will load only the kernel portion, not the application portion. Again, as all of you know, as all of you know, there are 2 components of an operating system. One is apps, applications, and another is the services. Services are also called as a kernel. So, loader is responsible for loading only the services. So, where it will load? From hard disk to, what is the meaning of loading here? From hard disk to RAM it is loaded. Correct. Now, can I say all the managers are started executing, started ready in this stage? All the important managers are going to become ready in this stage, in a kernel stage. Apart from that, in a kernel stage, what you called file system gets mounted. One of the student video is on, please switch off it. Apart from that, will you agree the file system gets mounted? What is the meaning of file system gets mounted? If file system is not going to be mounted, can we access the files? We means as a user, can we access the files in the hard disk? If RAM, if your pen drive is not mounted to your system, can you access the data from the pen drive? No. Similarly, file system gets mounted. Now, can you tell me which is the first process under the control of operating system starts executing? Which is the first process under the control of operating system is going to execute? That is init process. Init process runs in the user space or in a kernel space? Init process runs in a user space or in a kernel space? Answer is user space. What is the job of this init process? The job of this init process is to execute the run level programs. Run level programs means small services. And also in this run level, which run level my system should run, it is decided. Multi user environment, single user environment, network enabled, network disabled, like this. After this booting steps, we started thinking about, after the concept of booting steps, we started thinking about a process. So process is nothing but the program which is loaded into the RAM for execution is a process. As all of you know that our C code never executes. Will you agree? All of you know that our C codes never execute. So normally what we'll do, we might have written a C program or C++ program. After writing the program, we'll compile the program. When we compile the program, we'll get one executable file in a hard disk. When this executable file, when it is loaded into the RAM, it becomes a process. When this executable file, when this ADAT is loaded into the RAM for execution, then it called as a process. Will you agree? The size of this file and the size of the process is different. Will you agree? The size of the file and the size of the process is different. Will you agree? The life of the executable file and the life of the process is different. The life of a process starts when you write dot slash adatout enter button. Life of a process starts when you write dot slash adatout enter button. And life of a executable file, if you use rm command, until and unless if you don't use rm command, so the file will be there in a hard disk permanent. Correct. I hope that's what in a previous lecture we are trying to understand. That's what in a previous lecture we are trying to understand. So today, first we need to start working on the background process and foreground process. Today, first we need to understand the background process and the foreground process. So for that, observe background process and the foreground process in a current terminal. Now, will you agree this is one terminal? This is one application called a terminal. All of you are observing. This is one application called a terminal. This is called as a command prompt. Huh? This is called as a command prompt. So, if you see the last lecture, in a last lecture, I written one program. In a last lecture, I written one program called Hello World program. Now, can you tell me what is the job of this Hello World program? If I execute that program, if I execute this program, hello is printed, you're getting 37. What is this 37? What is this 37? This 37 is called as a ID of the process ID. ID of the process ID. Now, when very simple explanation, will you agree? We provided you one separate ID like V19B8, A18, V19B9, V4. Can you tell me what is the aim? What is the concept behind providing an ID? Why we are not recognizing you with a name? Why we are not recognizing you with a name? Answer is very simple. There may be a chance that two different students may have the same name. So to identify uniquely, we already provided a ID to you. Similarly, now observe. Let's open one more. Terminal. Yes, for uniqueness purpose. Now observe. CD Linux process management. If you see here, two ADATouts. If you see here also I written ADATout enter button. Here also I written ADATout enter button. Here the process ID is 37. Here the process ID is 66. But the process is same. Process name is ADATout. Executable file name is a.out. Executable name is a.out. Now what happens background behind your sense is this is the hard disk. This is the a.out file. Now can I say there are two a.outs are present in the RAM. There are two processes are present in the RAM. You may get a doubt, sir, who is providing this ID? Answer is very simple, the process manager. Because the processes which are present in the RAM, who is responsible for managing it? The processes which are present in the RAM, will you agree? There are multiple processes are there. There are multiple processes are there. So if multiple processes are there, then there should be some responsible person to manage this. There should be some responsible person to manage this. Who is that responsible person is? Very simple, that is a process manager. I'll try to explain you in a little bit different way. Try to imagine, try to understand. Will you agree we are working in a multi-processing environment? In a RAM, in a RAM, apart from one a.out, apart from one process, there are multiple processes. Every process is responsible for. Now, can you tell me here how many processes I written? Can you tell me here how many processes are written? Will you agree? There are four processes. Hmm? Now, let's imagine only one CPU is there. Only one CPU, one processor is there. Only one processor is there. You may get a doubt. How these four processes can execute? Observe, only one CPU, single CPU, but there are four processes are executing. This is also in a while one. 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 One resource, multiple processes want that resource. Will you agree? There should be some responsible person to manage that. There should be responsible service to manage that. Can you tell me who is that? Very simple. Who is that? A process manager. Now, what is the job of a process manager? What is the job of a process manager? The job of a process manager is to manage the processes and the CPU. What is the job of a process manager? Means the job of a process manager is to manage the processes and the CPU. So, for managing purpose, what the process manager will do, whenever a process is created, whenever a process is admitted, so process manager will assign one unique ID. Process manager will assign one unique ID to that process. That is nothing but a process ID. Process manager will assign a unique ID to that process. That is nothing but a process ID. Will you agree? Now, try to think, try to imagine user point of view. Try to imagine user point of view. What user feels? User feels that this application is also running, this application is also running, this application is also running, this application also running at a time. Will I accept this statement? User feels that all these four processes are running at a time. But actually, one CPU is there. Will you agree? Four instructions cannot be executed. If only single CPU is there, will you agree? Four instructions cannot execute. Again, one CPU at a time it can execute only one instruction. Yes or no? Single CPU At a time, it can execute only one instruction. But user point of view, tell me, user point of view, what user is feeling? Will agree, user is feeling all these four applications are running, four processes are running at a time. But when you think about a low level, one CPU cannot execute four instructions at a moment. One CPU cannot execute four instructions at a moment. Then who is responsible for managing that? Who is responsible for managing that? That is the job of a process manager. That is the job of a process manager. Got the point? Now, in this also, while one is there, in this also, while one is there, in this also, while one is there, in this also, while one is there. While one means, what is the meaning of while one? Can I say these instructions should execute continuously? Will you agree? These instructions are always true every time it will execute. So, one CPU, one CPU and multiple processes, one CPU and multiple processes are there to execute. So then who is responsible for managing it? Very simple, process manager. What user is thinking? User point of view, user feels that all four my applications are running. But this CPU, single CPU cannot execute, single CPU cannot execute multiple instructions at a time. So who is responsible for creating such environment to the user where user can feel that all my applications are running? Answer is the process manager. Now we should not use the term called OS. Now we need to use a specific term called a process manager. Process manager job is to manage. Can anybody type the answer? Process manager job is to manage the processes and the CPU. Process manager job is to manage the processes and the CPU to achieve multi processing environment, to achieve multi processing environment. Is this point is clear? Process manager job is to achieve multi processing environment. Process manager job is to manage the processes and the CPU to achieve the multi-processing. Now, one more thing here, you need to understand one term. You need to understand one term. Now, one question is, in every process, in which memory section the instructions are there? Try to understand the question very carefully. Every process is having a stack section. Every process is having a data section. Every process is having a code section, heap section. So, in a process, in which section the instructions, opcodes are there? Yes, correct. Code section. Now try to imagine the environment. Little bit tricky discussion. Try to observe. This is the P1 process. Okay. This is the P2 process. This is the P3 process. P1 process is having 1000 instructions. How many instructions? 1000 instructions. P2 process is having P2 is also having 1000 instructions to execute. P3 is also having 1000 instructions to execute. Observe. How many processes? Tell me, how many processes? Here I written three processes. How many instructions each process is having? How many instructions each process is having? Suppose 1,000 instructions. Now observe, there is a CPU. CPU means, can I say, there is a processor. There is a process manager. What is the job of a process manager? Will you agree the job of the process manager to allocate a CPU time to P1, to P2, to P3. Now, with this example, I'm trying to explain you what is the concurrent execution and what is the sequential execution. With this scenario, with this situation, I'm trying to explain you, I'm going to explain you what is the sequential execution, what is the concurrent execution. Getting the point? With this example, I'm going to explain you what is the concurrent execution, what is a sequential execution. Now tell me, there are three processes are there, P1, P2, P3. Only one CPU is there. Then who is responsible for managing this? Who is responsible for managing these processes and the CPU? Definitely the process manager. Now try to understand what is the meaning of sequential execution. Suppose process manager first it given the CPU time to P1 process. Total completion of P1 instructions. If P2 starts executing, and after total completion of P2, if P3 starts execution, then such environment is called as sequential environment. After total completion of one process, total completion means what? What is the meaning of total completion? After total completion of one process, means in our example, first process is having 100 instruction. So after 100 instructions completion, 1000 instructions, sorry. After 1000 instructions completion, if another process will get the CPU time, after that process 1000 instructions completion, another process starts executing. Such environment is called as sequential execution. Multi-processing and sequential execution. Sequential means after one process total execution completion, another process. Is this point is clear? Is this point is clear? Sequential means after one process total instructions completion, another process will get the CPU time. After another process total completion of, another process will get the CPU time. Sequential. Concurrent means, observe what is the meaning of concurrent. Suppose first CPU time is given to the P1 process, but not total instructions. Only few instructions are executed. Remaining instructions are pending. Then CPU time is given to another process. Only few of the instructions are executed. Remaining instructions are pending. Then P3. Only few instructions are executed. Remaining instructions are pending. Again, this rotation takes place. Now tell me, such type of execution is called as concurrent. The meaning is, what is the meaning of concurrent execution means? Before completion of one process execution, if another process will get the CPU time to execute, then such environment is called as concurrent execution. Before completion of one process execution, I'll write it here. Concurrent execution. Before completion of one process instructions execution, If another process gets the CPU time to execute, such situation is called as concurrent execution. You may get a doubt, but at a time only one process run in the concurrent. Yes, in a single CPU environment, in a concurrent also at a time only one process will run. If your CPU is only one CPU. Yes. If a CPU is a single CPU, before completion of one process total instruction execution, if another process starts executing, so then that environment is called as a concurrent execution. Now, is this point is clear? I'm talking about a one CPU. Then what about the multi-core and hardware multi? That's what we need to discuss. What is the hardware multiprocessing? What is the software multiprocessing? We need to discuss about hardware multiprocessing, software multiprocessing. Observe. In a hardware multiprocessing, hardware multiprocessing, for every process, in hardware multiprocessing, for every process, dedicated CPU will be there. In hardware multiprocessing, for every process, dedicated CPU will be there. Now tell me, this process execution never going to be disturbed, because for that a separate CPU is allocated. Dedicated means a separate. Dedicated means separate. For application 1, CPU 1 is reserved. For application 2, CPU 2 is reserved. For application 3, CPU 3 is reserved. For every application, there is a separate CPU is allocated. Such environment is called as a hardware multiprocessor. But if you see the right side of this, application 1, application 2, application 3, one CPU it is sharing. This is called as application 1, right side, application 1, application 2, application 3. These three processes are sharing single CPU. Then it is called as a software multiprocessing. Then it is called as a software multiprocessing. Now tell me, in your mobile phone, octa-core processor is there. Octa means suppose in your mobile phone, octa-core processors. Will you agree? 8 CPUs are there. Now can I say here 8 instructions can execute at a time? Every CPU will execute one instructions. Can I say 8 instructions can execute at a time? Listen, now you need to feel, you need to understand, is this environment is a hardware multiprocessing or a software multiprocessing? Now you need to understand, this environment is a hardware multiprocessing or a software multiprocessing? Answer is still software multiprocessing only. My question, very straightforward question. In your mobile, do you think that only 8 applications can run? In your mobile, do you think that only 8 applications can run? No. So then, now can I say CPU 1 is going to be allocated to multiple applications and CPU 2 is going to be allocated to multiple applications. CPU 3 is also going to allocate to multiple applications. Now you tell me, is this environment should I call as a hardware multiprocessing, or still should I call a software multiprocessing? If suppose your mobile phone environment where operating system is there, if suppose it is a hardware multiprocessing, 8 CPUs are there, at a time you can run only at a time you can run only 8 apps. You cannot run more than 8 apps. But the current scenario is you can run more than 8 apps. Even though multiple hardwares are there, can I say this is not a hardware multiprocessing? Still, this environment is the software multiprocessing. A18 is asking how it is. Now, for that, very simple. That is the job of the process manager. Suppose there are multiple CPU, octa core. Let's take a quad core. Can you tell me what is the meaning of quad core processor? Quad core processor. Now, can I say 4 CPUs are there? CPU 1, CPU 2, CPU 3, CPU 4. But this CPU is going to be allocated to P1, P2, P3. Suppose. Now, can I say who need to share the CPU 1? Who need to share the CPU 1? Who need to share P1, P2, P3, P4, P5, P6 given to P7, 8 and 9 given to this, 10, 11, 12 given to this. It is not the meaning that if your system is having a quad core, only 4 applications you can run. Will you agree? More than 4 applications can run. So can I say still it is a software multiprocessing? One of your friend asked one question, sir, example for hardware multiprocessing. See, designing hardware multiprocessing for general purpose applications is very difficult. Again, designing hardware multiprocessing environment for general purpose applications is very difficult. Now, suppose I'm going to design one multiprocessing environment where I'm going to design one multiprocessing environment where 20 processes are going to run. Now tell me, if 20 processes are going to run, 20 processes are going to run in my embedded product. Now, if I want to design hardware multiprocessing, how many CPUs it required? How many CPUs it required? Will you agree? I need a 20 CPUs. Can I say hardware cost increases? If in case your processes are restricted, in case your processes are restricted means I need to design a system where maximum of 4 processes I need to allow to execute, not more than 4. Then I can create this environment. I can create this environment, software multiprocessing or hardware multiprocessing. Suppose I need to design one embedded product. I decided that in that not more than 4 should not execute. Then can I design a hardware multiprocessing or software multiprocessing? I can go for hardware multiprocessing. I can go for hardware multiprocessing. Now my one very straightforward question is, in which environment the performance is too good, in hardware or software? In hardware multiprocessing, the performance is too good. G7 is asking some question. Let's see. G7 is asking one question. CPU is hardware in software multiprocessing and hardware. G7, I don't know what's your question. Even though in my in your laptop, quad core processor is there, octa core processor is there, still that environment is a software only. Because if octa core processor is there, you can run more than 8 applications. Meaning is more than 8 applications can execute, but not at a time. At a time only 8 can execute because 8 octa core is there. Still it is a still it is a still it is a software multiprocessing. Now you tell me, in your mobile phone, in your mobile phone, in your mobile phone, 8 CPUs are there. Should I consider that environment is a 8 CPUs are there? Should I consider that environment is a should I consider that environment is a yes? We need to consider as a software multiprocessing. And one of your friend is asking, sir, what is an example for hardware multiprocessing? Now, if you go for search engine like a Google search and whatever it is. Now, in that case, what happens is when I send a request to the Google machine, Google Drive or Google server, so for me, it need to allocate a separate CPU until I said until my work is completed. In that case, in that case, will you agree? Hardware multiprocessing will give the more good performance. Hardware multiprocessing will give the good performance compared to the software multiprocessing. How many of you know that the Google server, how much area the servers will occupy? How many of you know that? How much area? Will you agree? It will take acres of land. Huh? It will take acres of land. Why? Because very large. We can't imagine it also. Why? Because the search engines, the database, whatever it is maintaining, whatever the searching things, whatever the things are there. So for every user request, there is a dedicated CPU will be there. In that case, the performance will be high. Yes, sir. Yes, sir. In such cases, suppose I am designing one application. Suppose I am designing one embedded product where my embedded product job is to perform 3 tasks: task 1, task 2, task 3, or 4 tasks. Now tell me, if you are designing one embedded product for 4 tasks, will you prefer hardware multiprocessing or will you prefer software multiprocessing? Tasks are fixed. You don't have the another word that tasks are going to increase or decrease. Tasks are fixed. So then better go for hardware multiprocessing. But I don't know how many tasks I am going to user is going to user is going to like our applications. I don't know how many tasks and process is same. Yes, the term task and the process is same. I don't know. That purely depends upon the user point of view. Then we need to go for a software multiprocessing like our mobile. Have you observed when your laptop or when your mobile is going slow, you will kill the background processes? Yes, sir. When your application is going slow, why it is going slow? What is the why what is the meaning of it is going slow? Can I say so? There are multiple processes are there, and CPUs are less. So what happens is the time whatever it is getting is less. So that's why it is becoming a slow. We feel that it is becoming a slow. So then we'll free the RAM space. We'll kill the background processes like this. Again, I am requesting you within a single day. It is impossible to imagine everything. This is a continuous process. Slowly, you need to understand. I can understand you may have so many questions in your mind. All these questions are going to be clarified day by day. Got the point? Huh? I hope it is clear. What is a multiprocessing? What is a sequential execution? What is a concurrent execution? What is the meaning of sequential execution? After total completion of one process execution, if another process starts running, such environment is called as a sequential execution. Suppose my environment is a sequential environment. This is a P1 process. This is a P2 process. This is a P3 process. Suppose my environment is a sequential environment. What is the meaning of sequential? After total completion of P1, then only P2. After total completion of P2, then only P3. Suppose my environment is a sequential. Suppose this is in a while one loop. Now tell me, P2 will get the chance to execute or not? Suppose my environment is a sequential environment. My process manager is allocating the CPU time to a processes in a sequentially, means after total completion of one, another for P2 it will allocate. So this P1 is a while one loop. If this P1 is a while one loop, P2 and P3 will get the CPU time slice or not? CPU time or not? Answer is, can I say no? H1 is asking one question. In software multiprocessing, which one will come out from CPU application 1, application 2? See, for that you need to understand scheduling policies, H1. You need to understand the scheduling policies. Normally, 1, 2, 3 means, we'll say first one, second one, 2, third one, 3. One of your friend is asking, S7, sir, applications are running sequentially or concurrently? Applications are running sequentially or concurrently. Observe, observe. Very good question. Observe. This is the CPU 1. This is the CPU 2. Let's consider dual core processor instead of discussing the quad core, octa core. So let's consider the dual core. Dual core means, let's consider the dual core. Dual core means two CPUs. Suppose what the process manager did is, suppose this is a process manager. Just give me some time. Suppose this is a process manager. This process manager given CPU1 to P1, P2, P3. Observe, CPU1 is allocated to which processes? In this example, CPU1 is allocated to which processes? P1, P2, P3. CPU2 is allocated to CPU2 is allocated to P4, P5, P6. Now you tell me, P1 and P2 concurrently they are executing or sequential? If you think in another way, P1 and P2 application wise, if you think, not the total environment wise, application wise, can I say P1 and P2 sequentially? Because at a time those are both are not executing. Now think about P1 and P4. Two instructions are executing, P1 and P4. In this way, if you think, applications are sometimes it is a concurrent, sometimes it is a sequential. Now these three are sequential. Compared to these three, this and this are concurrent. When I'm talking about a multi CPU environment, got the point? Now, whatever the discussion I'm going to do in this entire process management, In this entire process management, whatever the discussion I'm going to do, I'm going to do with single CPU environment. I'm going to do with single CPU environment. Is it clear? What is a concurrent environment? What is a sequential environment? Means concurrent environment means after total completion of before total completion of one process, if another process will get the CPU time slot to get, then it is a concurrent. Sequential means after one queue will be there, like a queue. First P1, after completion of P1, P2, after completion of P2, P3, after total completion, one by one. I hope this is clear. I hope all of you got a little bit clarity about hardware multiprocessing, software multiprocessing. I hope all of you got a little bit clarity about what you called sequential execution, concurrent execution. Sometimes I'll use the term called process. Sometimes I'll use the term called task. Every program is responsible for performing some operation. Every program is responsible for doing some work. Is booting is a concurrent or sequential? Good question. Booting is a concurrent or sequential? Answer is sequential. Booting steps is a sequential. After total completion of BIOS, then it will go to MBR. After total MBR, then it will go to the grub. After that, give the control to kernel. After that, it will give the control to init. That is. Once the booting process is done, all the managers are concurrently executing. Once the booting process is done, once you provide a login ID password, so then all the services are concurrently executing. Okay. Now try to imagine here. Now here multiple applications are running. Will you agree? Here multiple applications are running. Is it a concurrent or sequential? Here multiple applications are running. Should I consider this as a concurrent or sequential? Answer is it is a concurrent. Even though one downloading is not completed, you can upload it. You can listen the song. You can speak with somebody else. Like multiple concurrently you can do it. Concurrently you can do it. Even though one process, one work is not yet completed, you can do another work. Even though one work is not yet completed, you can do another work. Now, what is a process management? Already we discussed. Process management is one of the service in a kernel. Will you agree? The process management is one of the service in a kernel. Its responsible. Its responsibility is to manage all the running processes in the system. Its responsibility is to manage all the running processes in the system. Compared to hardware multiprocessing, in a software multiprocessing, process manager's role is very important. Observe this point. Compared to hardware multiprocessing, in a software multiprocessing, process manager role is very important. Will you accept this statement? Why? Because only one CPU is there. There are multiple persons want that CPU. So here the operating system role is very crucial compared to hardware multiprocessing. In hardware multiprocessing, one process yes given, another process yes given, another process yes given. There is no further work once it is assigned. But whereas in a CPU, time slice will be there. There's a concept called time slot. There is a concept called time slice. CPU time is going to be divided into slice. So first slice, one application. Second slice, second application. Third slice, third application. Next slice, again first application. A round robin or whatever the policy. Don't worry about now. Now, whatever the discussion is happening, will you agree this is generalized discussion? Yes, sir. So, will you accept this statement? Comparing to hardware multiprocessing, in a software multiprocessing, the process manager role is very important because one CPU need to be shared to multiple processes. One CPU need to be shared to multiple processes. Which process mostly prefer hardware? Which multiprocessing? See, if you are preferring hardware multiprocessing, you need to restrict yourself for multiple processes. Suppose I want to design a hardware multiprocessing. In my hardware, 4 CPUs are there. Now, can I say I need to restrict number of applications running? Hmm? But if 4 CPUs are there, if I allow more than four, can I say my environment user feels that yes, in my environment, 5 applications, 10 applications are running faster. But that little bit s- delayed, the delay we can't feel it now. Performance wise, if you see, hardware multiprocessing is good. But manufacturing wise, hardware designing wise, if you think, if you think, so if I want to allow the user to run 100 applications, I can't I can't create a hardware where 100 CPUs are there. Even if I create it also, the cost of the product increases. That's why I told you. In a general environment, software multiprocessing is better. Software multiprocessing is cost wise, yes, A8 correct. Software multiprocessing is better compared to the hardware multiprocessing. And you don't know how many processes are going to execute. That purely depends upon the runtime scenario. Then you can't go for a hardware multiprocessing at all. Software multiprocessing. T2 is asking in i3 i5 how many CPUs are there. Please try to google it, you will get it. T2 V19B8 T2 is asking in core i3 i4 how many CPUs are there. Please try to google it, you will get it the answer. Now we need to come back, and I hope you got what is this process ID. I hope you got this process ID. So process manager is responsible for providing one unique ID till the process is alive. Till the process is alive, that is nothing but a process ID. Why process ID? To identify the process's uniqueness. So process manager will give one ID. Now observe, here also a dot out is running. Here also a dot out is running. So to identify this a dot out and this a dot out, process manager is given one unique and number that is called as process ID. Can I say this process ID is 37? This process ID is 66. Now the discussion is foreground process and the background process. Now tell me, now you tell me, here my process is running in the foreground or background? In this terminal, my process is running in the foreground or background? Answer is, in this terminal, my process is running in the foreground. Because of that reason, I can't I can't give the command here. Will you agree? Now the discussion is foreground process and background process in a current terminal. In a current terminal, this is technically called as a terminal command prompt. So when my application is running in the foreground, can I say I can't communicate with a command prompt? When my application is running in the foreground, will you agree I can't communicate with a command prompt? Now, can anybody tell me how to terminate this process? Control C. Will you agree? When I press a Control C, my process gets terminated. I don't know, you remembered or not, when I started with the for loop, while loop, I told you, if your program is not under your control, you want to terminate in middle, you need to press Control C. Now, can I say now, Control C means we are terminating the process. Now, in another way, can I say, with respect to process operating system point of view, can I say, when I press a Control C, my process gets terminated. When I press a Control C, my process gets terminated. Hmm? Now, when I simply write dot slash a dot out enter button, when I simply write dot slash a dot out enter button, will my process execution starts in a foreground or in a background in a current terminal? Again, when I simply write dot slash a dot out enter button, will my process execution starts in a foreground or in a background? Answer is foreground. When one process is running in the foreground in a command prompt in this terminal, I can't communicate with the command prompt. I cannot type ls command. I cannot type pwd command. Why? I cannot type ls command. I cannot type pwd command. Why? Because my process is running foreground in this terminal. Now observe, if I want to run your process in the background, very simple. Dot slash a dot out ampersand symbol. Suppose if you want to run your process in a background in a current terminal, if you want to run a process in a background in a current terminal, we need to type dot slash a dot out. Instead of directly pressing enter button, now you need to type and symbol. Now observe, all of you are observing here. This is called as job ID. Job ID is different, process ID is different. This is called as a process ID. What is a job ID? We'll discuss it. Don't think now. Who will assign this job ID? We'll discuss it. Don't think now. Process ID, who will assign? Who will assign the process ID? Process ID, who will assign? Process manager. Now the thing is, when I type ampersand symbol here, my process starts running in. When I write ampersand symbol here, my process starts running in. My process starts running in background, in a current terminal. My process starts running in background in a current terminal. Now what I'll do, in this terminal, I'll terminate it, Control C. Now observe, when I type PS, can I say one process is running in the background? ID is 68. I need to tell you one thing. Already all these commands are there. Once again, I need to write it here. PS is a command to display the processes which are present in current terminal. Current terminal. When you type PS and enter button, when you type PS and enter button, it will display the processes which are running in a current terminal. Now observe, in this current terminal, leave it about what is the bash, leave it about. Now tell me, when you type PS, when you press an enter button, can I say this is also becomes one process? Any command when you execute, it becomes one process. Very important point. Any command when you type ls, it is also one process. Ls enter button, PS enter button, PWD enter button. Are you getting the point? Is all of you are getting the point? Any command when I execute, it becomes a process. If you accept this statement, type 1. Any command when I execute, it becomes a process. Any command when I execute, it becomes a process. Yes. Now, in this, when I type PS, all of you are observing there are three processes are there. There are three processes are there. One is a bash. Don't worry what is the bash and all other things. We'll discuss it. Second one is our focus will be on this a dot out. Now a dot out is running from last. Now will you agree? Now the time definitely might have increased. Now the time definitely is increased from last 3 minutes 18 seconds it is running while one. My question is, this a dot out process is running in the background or a foreground? This a dot out while one semicolon is running in the background or a foreground? Answer is, it is running in the background. Because it is running in the background, foreground I can communicate with a command prompt. Because it is running in the background, foreground I can communicate with a command prompt. Suppose my a dot out process which is in a while one, if it is might have running in the foreground, I cannot communicate with the command prompt, I cannot type these commands. How to make my process to run? How to make my process to run in a background, in a current terminal? How to make my process to run in a background, in a current terminal? Very simple. Dot slash a dot out, ampersand. When you make ampersand symbol, my process starts running in the background. Now you tell me, when I type once again dot slash a dot out ampersand, what is the process ID? Now what is the process ID? What is the process ID? 71. Now observe. Can I say, will you agree there are two a dot outs are running? There are two a dot outs are there. R1, please wait, you will get a clarity on it. Please wait. R1. Now observe, concentrate on this a dot out. One a dot out process is running from the last 4 minutes 56 seconds. Another a dot out process is running from the last 09 seconds. Is it in a running in the background or foreground? Is it these two a dot outs are running in the background or foreground? Can I say these two are running in the background? Because these are running in the background, I can communicate to command prompt in the foreground. One more a dot out, dot slash a dot out ampersand symbol. Now 75. You may get a doubt, sir, if it is running in the background, how hello came? You may get a doubt, if it is running in the background, how the hello came? So printf cannot print the data in the background. In this terminal, whenever you use a printf, it should come in the foreground only, in the front only. But while one semicolon is there, if you observe the code, will you agree while one semicolon is there? Now let's observe. There are three a dot outs are there. 75, 71, 68. There are three a dot outs are there. 75, 71. I'll write it here. 75, 71. Which came first? Which a dot out came first? Which a dot out is created? Which process is created first here in these three? Then I say 68. Okay. Now observe, if I type fg, this is one more command. This is one more command. When we type fg, it will come, one process will come to the foreground. Again, If you type FG, one process will come to the foreground. I'm pressing Control C. Now, can you tell me which process? When I type FG, in these three A dot outs, one A dot out came to the foreground. I pressed Control C. Can you tell me which A dot out in these three A dot outs came? Can I say last one? Can I say this FG command follows last in first out? This FG command follows when you type simply FG, it will follow the last in first out. What is the meaning of FG? What is the meaning of FG? The meaning of FG is the processes which are running in the background to move back to the foreground, to bring back to the foreground. A18, I don't know what is your question. A18, what is your question? Dot slash A dot out ampersand symbol means my process is going to run in the background in a current terminal. My process is going to run in a background in a current terminal. So the benefit of background processes is foreground you can do some other work. The benefit of background processes is those are running in the background. Foreground you can do some other work. How to bring back that background to the foreground? FG. Sorry. Control C. One more FG. Control C. Now when I type FG now, observe what is showing. When I type FG now, what it is showing? Can I say there is no background processes currently? Will agree? Huh? Empty. There is no background. Now once again observe. All of you very carefully try to observe. Dot slash A dot out ampersand. Now tell me what is the job ID and process ID? What is the job ID and process ID? Job ID is 1, process ID is 79. Okay. Now, what is the job ID and process ID? Job ID is 2, process ID is 80. I'm trying to run these processes in a background only for the time being. Job ID is 3. Very important observation. Process ID is 81. Now the question is, when I type FG, which process will come back to the foreground? When I type FG, which process will come to the foreground? Last in, first out. But my requirement is one particular process I need to bring in between one process I need to bring to the foreground. If you normally simply type FG, last in, first out. But in middle one process, observe FG space job ID. Now can I say which A dot out came now? Which A dot out? FG space 2. Can I say 80? Now I am pressing a Control C. Now let's see. Can I say 80 is not there? 79 is there? 81 is there? So what I means to say you that when you simply type FG, press enter button, it will follow the mechanism called last in, first out. It will follow the mechanism called last in, first out. But if you type FG space job ID, only that particular job whose ID is 2, it will come out. Again, you may get a doubt, sir, who is assigning this job ID? Answer is, this job ID is assigned by the shell or terminal, we can say. I should not use the term called shell because most of you may don't know what is the shell. We need to discuss later. So for the time being, if I ask you who will assign the job ID means, current shell or current terminal. Now tell me, how should I get this process to move to the foreground? How should I get fg space 1? One of your friend is asking, sir, there are so many background processes, why it is assigning? See, whatever that background processes are running, those are running in a current terminal only. Whatever the discussion is going on, that discussion is with respect to current terminal, not the entire system. D2, got the point? Now observe, if I type fg, now dot slash a dot out ampersand symbol, what is the process ID? What is the process ID? 84. What is the job ID? 1. Now, now observe, let it be like this. I'll open one more terminal. Observe very carefully. When I write dot slash a dot out, ampersand symbol, observe here also 1. But process ID is different. Here also 1, here also 1. I don't know you observing or not. See, this job ID is with respect to that terminal. That job ID is with respect to that terminal. I will agree, I opened the two terminals here. Process ID is not with respect to that terminal. Process ID is entire here Linux subsystem processes. I hope you are getting this. Now, when I type PS, you may get a doubt. Job IDs are always sequential. Yes. And process IDs may not be. Because in this terminal, whatever the processes are running, going to the background, it is in a sequential way. Now tell me, when I type a PS, 84 it is showing, but 85 it is not showing. 84 it is showing, 85 it is not showing. What is the meaning of this is, PS command will display the list of processes in a current terminal. But when you type PS-E, when you type PS-E, entire Ubuntu processes. See, now you'll observe 85 also running in the terminal 1. This is a terminal 1, this is a terminal 2. Yes, job ID is assigned by the current terminal. For the time being, job ID is assigned by the current terminal. Got the difference between the PS and PS-E? Now, one interesting point about, we need to discuss it. Now observe, this is the terminal 1, this is the terminal 2. Here the process ID is 85. Here the process ID is 84. Will you accept this statement? Otherwise, I'll once again PS-E. 85 process is running in the terminal 1. 88 process is running the terminal 2. Will you accept? Now my requirement is, I need to terminate that process. Now tell me, what I told you to terminate that process? What is the procedure I told you to terminate that process? You can't press Control C. See, if I press Control C, observe, still 84 is there. If you press Control C, will agree? Yes, sir. So then what you need to do, you need to type FG. FG means to foreground. Then we press a Control C. Will you agree? I need to make that as a foreground. Then I need to press a Control C. But another method is there. You can use one command called kill hyphen 985. Kill hyphen 984. 85, 84 is the process IDs. Observe. All A data are terminated. Kill is a command to send a signal to a process. All these are there in a material. Kill is a command to send signal to a process. Signal means interrupt. Around 64 signals are there. You might have remembered. Kill is a command to send a signal to a process. Around 64 signals are there. Hyphen 9, if I am using kill hyphen 9 PID. 9 is forceful killing. What is a forceful killing and all other things? Once we started with a signal handling, we'll discuss it. Kill is a command to send a signal to a process. G5 got the answer. G5 got the answer. A8, A18 got the answer. 9 is nothing but a forceful killing. How many signals are there? 64 signals are there. Later, one by one, we'll discuss it. So why I introduce this kill command? Suppose without pressing the Control C, suppose I don't want to press a Control C, I don't want to move that background process to the foreground, but still I want to request is FG command. Here it is the foreground and background. FG command. Got the point? What is the shell? We need to discuss it. And please download. Please download this material. All of you downloaded this material? If you want to terminate all processes, yes, it is possible. You can, for that, you can go for, there is a man page. Every command, there is a man page will be there. Send a signal to a process. So go through this, you will get some information. Is it clear? Go through this, you will get a information. I'm not discussing the things which are not provided to you. Yes, I'm discussing whatever the things I provided to you, and you can open the man page, you can find out. You can open this, what you called PPT which I shared, you can open the PDF which I shared. That's what the discussion is going on. PS command. All of you are observing jobs, job ID given by shell. I told you job IDs are given by, I told you command prompt, but actually it is a shell, but we don't know what is a shell. We are not yet started discussing what is a shell. Then we'll discuss what is it. All of you are observing FG command is there. Please try to. And no need to No need to download other books or other things. Just our material is enough for this. Memory layout. All of you know memory layout. Data section, BSS, stack section, heap section. Will you agree? Memory layout of a process. Executable file contains only this. Already you know. When it is loaded, other in memory will be there. What is the shell? So we'll discuss this in a tomorrow's lecture. Got the point? First 1 2 days or 2 3 days will be like this theory only. After that, the programs will start. Very tricky programs will be there. This is our Linux material. This is shared in a. This is chapter wise. We are sharing it. This is there in your drive. Process management theory and process management programs. There are two PDFs are there in a Google Drive, and this is shared in a Moodle. Yesterday, this is shared in a Moodle. It's clear. Thank you very much for attending it. So tomorrow we'll discuss some more things about the kill command, some more things about the PS, some more things about shell, some more things about some definitions we need to discuss, like turnaround time, response time, starvation time. So there are so many things we need to discuss it. Okay, then I'm going to stop this discussion.